Hello and welcome to All Things Air Quality. This is the fifth video in the series and it is a follow-up on the fourth video on how to determine the stack gas moisture content using EPA method 4. This is just an example of the calculation. You went to site and this is the parameters that were recorded. It's a DGM volume of 1.2 cubic meters. Your impingers collected 10 milliliters of water, so you started with 200 milliliters, you finished with 210 milliliters. The silica gel gained 5 grams in mass. Your average DGM pressure was minus 20 kilopascal, that's the gauge pressure. The temperature of your dry gas meter was 20 degrees Celsius, and for our purposes we are going to normalize using a pressure of 101.3 kilopascal and 298 Kelvin, which is 25 degrees Celsius. And the purpose of this calculation again, it is determine the moisture content in the stack, which is volume of water that we've condensed divided by the total volume that we've sampled. So I'm just going to keep that on the screen for us to look at as reference. So water fraction in the stack equal to the water volume that we sampled that we are going to remove in our condenser, since we're running silica gel in that condenser, divided by the total volume that we sampled, which is the volume going through our dry gas meter, plus the volume removed in our condenser. So there's the equation. First up, let's look at the volume in the dry gas meter. So we're going to normalize that. So the volume we recorded on site was 1.2 cubic meters. That's the delta over there. We go 1.2 and we normalize using our DGM pressure. I said this is minus 20 kilopascal gauge. Any normalization is done with absolute pressures and temperatures. So we take that to an absolute pressure saying it's minus 20 kilopascal from atmosphere at 101.3. We are normalizing to 101.3 and we are then normalizing the temperature, that is at 20 degrees Celsius, taking it to Kelvin by adding the 273 there, and 298 is for 25 degrees Celsius, or for 298 Kelvin that we are normalizing to. That gives us a normalized dry gas meter volume sampled. Okay, next term, we look at the volume of water removed in the condenser. That has two parts. It's the volume removed in the silica gel, as well as the volume condensed in the impingers. Silica gel is easiest, let's start with that. It is the mass change of the silica divided by the density of water in the gas phase. The mass change is 5, we recorded 5 grams, and the density of water in the gas phase, this is at 25 degrees Celsius and 1 atmosphere, it's 977 grams per normal cubic meter. See, I bring the N in for normalized because I'm working out our normal conditions. It's just an easy way to keep track of what's normalized and what not. There we get our volume of water removed in the silica in the gas phase at our normal conditions. Now we deal with the next term. This is the volume of moisture in the condenser in the impingers. We first convert it to a mass and then to a volume as per the previous video, but the end equation there is the volume condensed equal to the liquid volume multiplied by its density divided by the gas phase density. And in this case, we condense 10 milliliters of water. The density is at 4 degrees Celsius because that's a very reasonable assumption because your condenser is running quite cold. So it's 1 gram per milliliter in the liquid phase. So we're converting that liquid phase here on the top term to a mass. That will give us 10 grams of water that we've condensed. And then again, as for the silica gel, we divide by the density in the gas phase. So this is the gas phase volume of the water removed in the impinger. And now at the end, we have to add those two terms together as per this equation. So we have water removed in the condenser is the sum of the water removed by condensing it in the impingers plus the water that's entrapped on the silica gel. We do that, gives us the total water we removed in our condenser. And now back to our initial, we want to know the water fraction in the stack. It is the total water removed in the condenser divided by the volume of gas we sampled through our dry gas meter plus the volume of gas we removed here in our condenser, substituting all the values. So volume removed in condenser, volume removed in condenser, and the volume through our dry gas meter, and we get our stack moisture content 0.015 or 1.5%. That is a relatively low value. This is a relatively dry stack. Please let me know if you have any questions or comments on this video.